Hello! In this lecture I will be teaching you how to count. What I mean by this is teaching you about multiplications, permutations, combinations and sums. Basically, it is the minimum of discrete mathematics you have to understand to solve problems. And as always, just stop the video if you need to reread something or think about something. As mentioned before, the ability to solve problems requires you to know how to count. Count in the right way, that is. Discrete mathematics is incredibly important for a programmer, as it provides him/her the insights to penetrate problems and create solutions. In case you wondered, yeah, logic is also part of discrete mathematics. I know that what follows seems so obvious that you may wonder why I mention it at all. Don't worry, you'll soon find that there is more to it than meets the eye. So let's begin with having a look at multiplication. If an event can happen in n different ways, and another event can happen in m different ways, then the number of ways both events can happen is n times m. Consider the following problem. Your friend has forgotten his password. He only remembers that it was made up of 2 digits, a letter and a single digit, in that order. He assumes you can hack the account for him in no time. If you can try 1 password per second, how long will it take you? Well, think about it. To calculate the time needed, we need to know the number of tries needed to find a password. There are 10 ways to choose the first digit. There are 10 ways to choose the second digit. There are 26 ways to choose the letter and 10 ways to choose the last digit. The total number of possible passwords is 10 times 10 times 26 times 10 is 26,000. The last one can be the right one, so all we can say is, you will find the password within 7 hours, 13 minutes and 20 seconds. That's easy, right? Right, but after 7 hours, 30 minutes and 20 seconds, you annoyingly find that nothing worked. Your friend suddenly seems uncertain about this formula. He remembers a new one. 3 digits and a letter. Think about it. Sure enough, another 7 hours, 13 minutes and 20 seconds later, your friend admits that even that last formula was wrong. What it really should have been is 2 digits, a letter or a digit, and finally a letter. How long will it take you now? Now, the total number of possible passwords is 10 times 10 times 10 plus 26 times 26 is 93,600. 26 hours later, hey, because it's always the last one you try, of course, you find his password. This example was about straightforward counting the ways in which an event can happen and multiplying the number of ways multiple events can happen together. We knew there were 10 ways to choose a digit and then 26 ways to choose a letter. Now consider this. In front of you is a jar containing chips. Written on each chip is a digit. The jar contains a chip for each digit 0 to 9. How many ways are there to draw 10 chips from the jar? This is confusing because there are 2 ways to do this. Either you put each chip back after you draw it, or you leave it out. Looking at the first case, we notice that every time we draw a chip, it can be 1 of 10 chips, because we put the chip back in the jar afterwards. Multiplication gives the solution. 10 times 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 10, or 10 to the power of 10. Now, if we do not put back the chips, for every draw there is one chip less to choose from in the next draw, and the solution is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 3,628,800. The second problem is a permutation problem. The definition of a permutation in mathematics is: permutation is the act of arranging the members of a set into a sequence or order. There is a name for the operation we perform to calculate the answer. Calculating 10 times 9 times 8, etc. is called calculating the factorial of 10. The mathematical notation for the factorial of n is n exclamation mark, or n faculty. N faculty is 1 if n is 0. For all natural numbers larger than 0, the factorial is the product of all the natural numbers from 1 to n. Let's look at another example. Given the sequence of letters, Zanydiculous, how many permutations are there of the letters? That means, in how many ways can you order all the letters to create other words? Well, we know now how to calculate that. There are 12 letters, so the number of permutations is 12 faculty, the factorial of 12, which is 479,1,600. If we would write them all down, we would find that a number of them are identical because the letter U occurs twice in the sequence. This one and that one. For instance, the permutation Zanydiculous with U1 here and U2 there is identical with Zanydiculous where U2 is here and U1 is there. If the question is how many permutations there are, our answer is correct. But if we want to know how many unique permutations there are, we are overcounting permutations of identical elements. If we want to know the number of distinct permutations, we need to introduce a correction. So if we have a sequence of n elements, and r elements of that sequence are identical to each other, then there are r faculty numbers of ways to reorder the identical permutations. Think about it. N faculty overcounts each distinct permutation with a factor of r faculty. So there are r faculty number of permutations in the total of n faculty too many, or overcounting them. The number of distinct permutations of a set of n elements in which r elements are identical is n faculty divided by r faculty. Applying the correction in our example gives 12 faculty divided by 2 faculty, which gives 239,500,800, half of the total, not surprisingly, of course. Now we return to our jar with chips. How many ways are there to draw 2 chips from the jar? Think about it. Just go about it systematically. For the first draw there are 10 ways, and for the second draw 9. So we find that there are 90 different ways to draw 2 chips from 10. It is easy to see that for 3 chips out of 10 the answer would be 10 times 9 times 8. For 4 chips out of 10, 10 times 9 times 8 times 7, etc. In general, if we draw k chips out of n, there are n faculty divided by n minus k faculty ways to do so. Let's have a look at that. N is 10, k is 4. The faculty of the factorial of n is 1 times 2, etc. times 10. For n minus k, that will be 1 times 2 times 3 times 4 times 5 times 6. Because 10 minus 4 is 6. So basically this is the factorial of 6. And that's written here. Now dividing the two, we'll just leave this bit. This will fall away against each other. This will cancel out. So you will have 7 times 8 times 9 times 10, which exactly is what we need. This is a very handy formula that can be used to solve many problems. From what we know now, we naturally arrive at combinations. A combination is a selection of items from a collection, such that unlike permutations, the order of selection does not matter. Imagine you have a deck of cards consisting of 52 cards. In how many ways can you deal 5 cards from the deck? It is not important in what order the 5 cards are dealt. What is important is that the resulting hand consists of a combination of 5 cards. Think about it. Okay, if we ignore these things and just go on treating it like a permutation problem, we would say, well, the number of permutations of 5 out of 52 is 52 faculty divided by 52 minus 5 faculty. And that would be 52 times 51 times 50 times 49 times 48. And that's another big number, which is 311,875,200. We know this is not correct because we overcounted many hands that have the same cards, only in a different order. You should by now be able to figure out how to correct this. We need to know how many permutations are possible of 5 cards. The answer is, of course, the factorial of 5. So we overcounted the number of combinations with a factor of 5 faculty. This means that we need to divide the number by 5 faculty. And then the real answer is 52 faculty divided by 5 faculty, which is the correction, times 52 minus 5 faculty. Which is not so big a number, still quite big though, but 2,598,960, considerably less than the other one. In general, the number of combinations of k elements from a set of n elements is n faculty divided by k faculty times n minus k faculty. It is called the binomial coefficient, and the mathematical notation is as follows. Read this as n choose k, with n choose k equals n faculty divided by k faculty times n minus k faculty. Now, just to see if you get it, one last exercise on this subject. You are asked to assemble the best streetball team possible. You get 20 hopefuls. You want to test each possible team of 3 before deciding on the winning team. If you can test each team in 10 minutes, how long will it take you to test all possible teams? Well, think about it. Well, the answer is 20 choose 3. And if we want it in hours, we multiply by 1/6, and that gives us 190 hours. Now, quite often when counting things, you will find that you need to sum things. A capital sigma is the notation used for a sequence of sums. So this sum from 1 to n can be written as follows. You can read this in this way. The sum of every I from 1 to n inclusive. So just to go back here, I is the index, it starts with 1. It goes all the way to n, and what is this that going to be summed? It is I. So I will take the value 1, then it will take the value 2, then it will take the value 3, all the way to n, and it will be summed. Just I thought to make that a bit clearer. What is the answer to this particular sum? Well, you probably know the formula for this. N times n plus 1 divided by 2. It was Gauss who found this formula at the age of 10, which is quite remarkable, really. He knew how to count pretty well, that man. Anyways, let's see how he came up with that. The trick is to multiply by 2. So, if we multiply the sum here by 2, we get it twice. This whole sum plus the same sum again. The other trick is to combine the terms so they are all the same. So taking this one plus this n, and then this 2 plus this n minus 1, and this 3 plus this n minus 2, you can write all that out like this. Oh, and by the way, I just noticed that this should be trick, not tick, of course. Each term is now 1 plus n, so the result is n times n plus 1. Now we need to divide by 2, and we have our formula, n times n plus 1 divided by 2. Okay, this was a little intermezzo, but it illustrates that counting right is extremely important. Now let's see how this can help in real life. Suppose you need to travel by train from Malmö to Stockholm anywhere in the next 7 days. Hey, I am living in Sweden, so that's the example I came up with. You want to have the cheapest ticket, but ticket prices vary wildly and are dependent on both the departure and the return dates. Any pair is valid as long as the return date is after or on the same date as the departure date. How many pairs of dates must be checked to find the cheapest ticket? You may want to pause. 7 pairs begin on the first date, 6 on the second, 5 on the third, and so on. Only 1 pair starts on the 7th date. The total number of pairs that need to be checked is 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 28. We could have solved this problem just as well with combinations. How many ways are there to choose 2 pairs of dates from 7? Well, 7 choose 2, which is 21. But because departure and return can be on the same date, we need to add those 7 pairs, so the result is 28. We have seen that counting is not as trivial as you might have thought. Counting things in the right way is vital for getting the results you need for your solutions. Make sure you have a complete understanding of what I talked about in this lecture, because it will be needed in almost all types of problem solving. Probabilities are next, but let's leave that for the next lecture. So I hope you enjoyed this one, and see you in the next one. Bye bye.